So hello guys, today we are going to solve a Leetcode question that goes by the name count substrings starting and ending with given character. Okay, so it was Leetcode contest question. Okay, so the question number is 3084 and we now know about the problem statement. If we try to read the problem, if we try to read the title again, what does the title say? Count substring starting and ending with given character. So it says that you will have to count the number of substrings that are starting and ending with a character that is given. The title gives us a slight hint of what we need to do. Okay, now we'll try to read the problem statement and then we'll go on to the solution. Okay, so let us first try reading the problem statement. You are given a string S and a character C. Return the total number of substrings of S that start and end with C. Okay, so you are given a string S and a character C. You have to return the total number of substrings of S that start and end with C. Okay, so C is not a character here, it is a variable, character variable. Okay, so this character can be anything. What are substrings? What are substrings? If I just tell you what are substrings, so if this is my string, if ABC is my string, the substrings of ABC can be A, AB, and then ABC, or B, BC, or C. Okay, so the contiguous segment is known as the substring. Okay, contiguous segment is known as the substring. Continuous segment basically is known as the substring. Okay, continuous segment. Okay, okay. So what we are given is, what we are given with, basically if I just try to get you the question, A, B, A, D, A. A, B, A, D, A. And the character given is, character C is equal to A. Character C is equal to A. So I have to get all the substrings that start and end with A. Start and end with A. Okay. If I try to just analyze what are my strings that are starting and ending with A here. Okay, I'll start with the first index. Okay. Is A starting and ending with A? Basically, I'll just consider all the substrings and then tell you the answer. Okay. For this string, I'll consider all the substrings. It can be A, it can be ABA, it can be AB, it can be ABAD, okay, and it can be ABADA. Second is starting with B, then basically B, then BA, then BAD, then BADA. Okay. Third, starting with A again, starting with this index. So A, ADA, and AD. These are my substrings. I come here starting with D, so D and DA. And then last, I come to this index, so A. Okay, so now I'll just traverse all the strings and I'll see what are my valid strings. Is A starting and ending with A? Yes, here's my counter. My counter is currently 0. My counter becomes 1. Counter becomes 1. I come to this index. Is the ABA string starting and ending with A? Yes. So my counter becomes 2. Is AB starting and ending with A? No. So I'll cross this. Okay. Is ABAD starting and ending with A? No. Is ABADA starting and ending with A? Yes. So my counter becomes 3. Is B starting and ending with A? No. Is BA starting and ending with A? No. Is BAD starting and ending with A? No. Is BADA starting and ending with A? No. Is A starting and ending with A? Yes. Yes. So my count becomes 4. C is 4 currently. Okay. I'll come to ADA. Is it starting and ending with A? Yes. Count becomes 5. Is AD starting and ending with A? Yes. Count becomes 6. Is D starting and ending with A? No. Is DA starting and ending with A? No. Is A starting and ending with A? Yes. So count becomes 7. So for this case, my count is 7. Let us try to see the answer. Okay. Have we just used any other substrings? Okay. So what are my substrings? A, ABA, ABADA, then A, ADA, and then A. Okay. So this is my valid string. This is my valid string. 1, 2, 3, then 4, 5. Not this. Okay, not this. So this 6. So this becomes answer 6. Okay, not 7. Basically, this is not a valid string. AD is not a valid string. Okay. So count becomes 6. Count becomes 6 for this case. Okay. If I just take one more example of ACA, where my character is gonna be A, character C is gonna be A. I'll just consider all the substrings. So one of my substring becomes A. What are my substrings? A, AC, ACA, then C, CA, and then A. Now I'll check for all the substrings. Is this valid? Yes. Is this valid? No. It is not starting and ending with A. Is it starting and ending with A? Yes. Is this starting and ending with A? No. Is this starting and ending with A? No. Is this starting and ending with A? Yes. So what are my valid substrings? 1, 2, and 3. So my count becomes 3 in this case. Count becomes 3 in this case. Okay. So this is our brute force solution. This can be our brute force solution. How? Basically, we can generate all the substrings. Okay. If this is what I am given with A, B, A, D, A, I can basically use two loops to generate all the substrings, first starting with character A and including for all these, okay, including all these one by one. And whenever I see that the substring has become equal to, like the substring is following the condition that is starting and ending with A, suppose this condition or this, okay. So these are my valid answers. These are my valid answers, and I am gonna be increasing my count for this. Similarly, I can start at B and I can consider all the substrings. I can consider all the substrings. I can consider all the substrings. I can consider all the substrings starting at B. Okay, I can consider all the substrings starting at A. I can consider all the substrings starting at D. I can consider all the substrings starting at D. A. Okay, so this can give me the overall answer. But if you try to see the time complexity of this solution, okay, so the substring generation would take O of n square time. O of n square time. It is not gonna take any extra space. Space complexity is gonna be 1, O of 1. Okay, but this time is what I have to reduce. This time is what I have to reduce, because if I just see the constraints, I cannot make, it is basically 10 raised to the power 5. So I cannot make all the substrings because it is 10 raised to the power 5 raised to the power 2. So it will become 10 raised to the power 5 whole power 2, that becomes 10 raised to the power 10. And this would take greater than 1 second. So this would not run. This would not run. Okay. So how can I do my optimal solution? How can I arrive to my optimal solution? Optimal solution. How can I arrive to my optimal solution? Basically, if you just see this test case, A, B, A, D, A, B, A, D, A, where my character is gonna be A, character is gonna be A. Okay. Now, if I just see this test case, what I am seeing at every index, basically, if I just start iterating, maybe from the back, okay, I'll just start iterating from the back. Basically, if I come at A, what I'll say is, what are the number of, what are like, how many characters before it appearing, like how many times the same character appears before, like if A is coming here and if A is coming here, if A is coming any time before the character, before the current position, okay, suppose I am iterating like this, my A is somewhere here. Okay, so for getting to know the number of substrings, for getting to know if there exists a substring that starts and ends with the same number, so let it be the ending number, let it be the ending character, let it be the ending character. So I'll check for every time if there exists a starting character also, like if there exists a here, okay, then I would just consider this substring, as my answer. And I will increase my count. I'll increase my count for this case. Okay. Now basically, if there exists one more A, that means this can also be the answer. So this would also increase my count. and if a exists here also, this would also be my answer. So it would also increase my count. And also this a is appearing alone as the answer, because this starting and ending character, this can be the starting as well as the ending character. So I have to include this also. Okay, so this would also increase my count. Okay, so the number of times substrings starting and ending with a appear here is basically the number of times a has appeared till now, the number of times that character has appeared till now. Basically, if I just consider this test case, uh, I'll just consider the example that is given. Okay, a b a d a d and a. Okay, so I will just make a map. I'll just make a map for storing all the characters along with their frequencies. Why frequencies? Why frequencies? Because this frequency will tell us if that character has appeared before, has appeared before, and if yes, if it has appeared before, how many times has it appeared? Basically, why we are checking this? So if we are at this index, if we are at this index, and if I consider the current index as my last index, of the string, last index of the substring. So this is starting at basically ch is my a. I have to look for a. So if my ending character is a, now I will have to check whether there exists a starting character also, and the starting character is basically how many times occurring, how many times. Okay, so if I have a starting character also, I can increase my count. I can increase my count I can increase my count, and this character would also solely increase the count, solely increase the count, solely increase the count. Okay, solely increase the count. How? See, if there is a substring like this, if there is a substring like this, like A B A C A. Okay, so if I am standing here, if I am standing at A, and this I know is the last position, this I know is the last position. So what I'll check is, are there any A's before? Are there any A's before? So if I get any A, if I get any A, that means the string starts and ends with A, starts and ends with A. Like you can see, right, this ends at a. So if I find any index that starts with a, that means if a has occurred before, that means it is the starting index, so my count would increase, okay. And if this can also be my answer, and a is here also, a is occurring here also, so this can also be my answer, so the number of times a has occurred, a has occurred before the current index, I have to add it to my count, because see, a is occurring two times here, one here and one here. Okay, so this both is adding up to 2, okay. So for this there exists two answers, basically first this string and then this string. Basically for this index a b a d a, for this character I have two options. If I have two options, either this can be my substring or this can be my substring. Okay, so as a is occurring two times, so if any of them can act as the starting character, okay, because I know the ending character, I have to just look for the starting character, right? So the number of times the starting character is appearing, that is the number of strings, that follow the condition, that follow the condition, okay, okay, that follow the condition, that follow the condition, okay, okay, that follow the condition. So 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 And also if I just try to see, this can be my starting character, this can be my starting character, and if I have identified this, this can also be my starting character, this can also be my starting character. How? Because if I consider the single character a, so a is starting at a and ending at a. Okay, so a is single also added. Okay, so if I just try to do the dry run of this test case, a b a d a. Okay, here is my map that will store the character with its frequency, okay, and I will just update the frequency first and then I'll get the answer. What I mean by this is basically I'll come at 1, I'll come at the first index, I'll come at this index. Okay, I'll come at this index, I'll come at this index, I'll just check if it is present in my map. No, it is not present. I'll just store it and increase its frequency. So my frequency of a is 1. Okay, and my character to be found is a, character to be found is a only. Okay, so I'll just check for it if a exists in my map. After adding it in my map, I'll just check if a exists in my map. Why I added it before? Because a can solely be my answer also, a can solely be my answer. So I have to add it to the map. I have to add it to the map so that this doesn't get ignored. Okay. So I will look for it in the map. Yes, it exists. So I'll add its occurrence. C plus equal to 1. My count becomes 1 for this test case. For the current index, my count becomes 1 for the current index. Okay. I'll move I'll move forward. I come to the B index. Is B present in my map? No. I'll just store B. Okay. And is B equal to my character? Is B equal to my character? No. So I won't have to check any other occurrence before it. Okay. I'll just move. Okay. But I'll store this. I come to A. And I'll increase my occurrence. I'll increase my frequency. So A becomes 2 times. A comes 2 times. Okay. So the occurrence of A becomes 2. Okay. And if occurrence of A becomes 2, I'll again check whether it is present in my map. Yes, it is present in my map. So my count would be increased by 2. Why? Because for the eighth index, I will have 2 options. Either this can act as a starting index, or this can also act as a starting index. So for this A, I can have 2 options. Either my starting index can be this, or my starting index can be this. Okay, so this index, this occurrence would be recorded first. And then it would be checked in the map. Because if I don't update it, assume that I don't update it first, and then I am added to my count. So this single occurrence would be ignored. So what I do first is I'll just first increment the frequency, and then I'll check it in my map. If it is existing in my map, I'll just add it to my count. Okay, it is added to my count. I'll just increment my index. Okay. Now I am pointing at D. Okay. Is D present in my map? No. I'll just mark it and increase its occurrence, increase its frequency. Okay. I'll come to A. Okay. Is A present in my map? No. First, what you have to do is you have to increase its frequency. Yes, because if I don't increase, then this element would be ignored. Okay. So I increase its frequency become 3. Okay. Then I'll check if it is present in my map. Yes, it is present in my map. Okay. So I'll increase it by 3. So my count becomes 3. 6 for this case. My count becomes 6 for this case. Is it the correct answer? Yes, 6. Okay. If I just try out the second test case, or I'll take this test case ADA or ACA. Okay. My C is equal to A in this case. This is my map, which will store its character and its frequency. Okay. I come to the first index. Okay. First I'll mark it and then I'll check whether it is present in map. Yes, it is present. I'll just increase my count by the number of times it is present, because the frequency determines that how many indexes the particular substring can start with, because this pointer is pointing at my last index. So if this frequency is 1, I can start with only a. Okay, I come at c, is it I'll just increase its frequency. Okay, but this character is not equal to my c, so I'll not increase my count. I'll increase my count only if the character is equal to my c that is given. Okay, I'll come to this, I'll increase this frequency, I check it in my map, and I'll check whether it is equal to my c. It is equal to my c, yes, so I'll increase my count. So 1 plus 2 becomes 3, 1 plus 2 becomes 3. So for this case, 3 is my answer. And if I just try to see how 3 is my answer, so these are the 3 substrings that will be my answer. This is the starting string 0 index, and this is the ending string 2 second index. Okay, if I just try to see this test case, z z z, and what is my c in this case? C is equal to z. C is equal to z. Okay, this is my map that will store the character and the frequency, character with its frequency. Okay, I'll come to the first index. I'll just store it. In my map. Okay, then I'll check whether if it is equal to c. Yes, it is equal to c. So my counter would be incremented by 1. Okay, so it becomes c. Counter will be incremented by 1. I come at the second index. I just store it. I'll increase my occurrence. I'll just store it. I'll check it in my map whether it is present. Yes. So 1 plus 2 becomes 3. So my counter becomes 3. Okay. I come here. Okay. I'll increase my frequency. I'll again check whether it is present in my map. Yes. Okay. So I again increase by this. So 3 plus 3 is equal to 6. 3 plus 3 is equal to 6. Is 6 my current answer? Yes. Okay. So this is what I am trying to do. If I just try to write the code for this case, what I first need is, I need an unordered map with which stores the character and the frequency. Okay, what I need is second is my count, and in this case the count is equal to be of type long log, because I have to return long log. Okay, I'll just iterate all the indices. First, what I'll do is I'll try to increase the occurrence of my character that I'm currently on. And what I'll do is, if my s of I equal to the element that I'm looking for, and it is present in the map, so I'll increase my count by the number of times it is present. Okay, and what I'll do at last is I'll just return my count. Try to run it. So let's see. Yes, it ran. I'll try to submit. Okay, submitted successfully. So as you can see, what I did is I declared basically an unordered map. My unordered map paved the way for basically storing my elements, basically storing my starting indices. If this is my ending index, how many starting indices are there, such that they start with the same character, one index is there, and this is the second index, because the last index can also be, if my string is this is my last index, and this is also my first index. So this will also be counted. That's why I am increasing my count first, and then I am increasing my count first, then I am looking for it, and then I am increasing my count. So, and then I'm storing it, this is what I'm doing. Okay, and I'm storing it, checking it, and increasing my count. Okay, if I just try to analyze the time complexity, as I'm moving only once, iterating only once, as there is only one pass, so my time complexity becomes O of n. Okay, and what is my space complexity? As I'm using a unordered map, so my space complexity becomes O of n. Is it O of n? No, no, because as we can see, the string only contains of lowercase English letters. So how many lowercase English letters are there? O of 26, that becomes O of 1. Okay, so my time complexity is O of n, and my space complexity is O of 1. Okay, so this was the overall solution to my question. count substring starting and ending with the character. I hope you guys like the solution. If you have any doubts regarding it, just bring it down in the comments. And if you like the solution, do like, share, subscribe. Thank you. Have a nice day. Bye bye.